All right. Yes, I'm Katie Rodriguez. I'm the biology branch chief for Caltrans District 9. We cover the Mono County, Eastern Kern County, and Inyo County, so pretty much all of the Eastern Sierra. I've worked in the Sierras for 13 years. I started my time in the Sierras in Yosemite National Park, where I actually did my master's thesis on a similar subject, bear vehicle collisions. So I've had a lot of experience and work in road ecology, which we'll talk about tonight. And I'll just give a warning, this subject can be kind of sad and depressing. So, I've given these talks many times, and so I just want everyone to know that, there is a lot of hope. There's a lot of solutions for wildlife vehicle collisions. So keep that in mind. It's a good ending to the story. Oop. Nope. We gotta do. Okay, I got it. Thanks. I'm going to talk about road ecology to kind of prime you guys on what that field of study is. We'll talk specifically about wildlife vehicle collisions, and we'll talk a little bit about wildlife crossing research and its effectiveness, and then we'll talk about the Mammoth Lakes US 395 crossing project, give you some background and the current status on the project. So road ecology. In a nutshell, road ecology is the study of how roads impact the environment. And specifically when we're talking about wildlife impacts, that can look like changes in the amount and quality of habitat for wildlife, which can include habitat loss. So, if you develop and build roads, now you have habitat that's converted to roads. So there's direct loss of habitat. There can also be habitat alteration, so indirect effects to habitat from roads being constructed, things like noise, lighting, human disturbance that can also have effects on wildlife. There's also something called the road effect zone. In the United States, about 1% of our land is made up of roads, but 20% of the land is in this road effect zone. So that can be from pollution from the road, again, noise, lighting, human disturbance, change in habitat. So that's a lot of area when you consider our entire country. Roads can also impact behavioral changes in wildlife. And so that can look like wildlife avoiding roads. If they approach a road and there's too much noise, too much traffic, they'll probably turn around and go back the way they came. There can also be the opposite, attraction to roadsides. Some places where, they use salt to de-ice the road, that can collect in the shoulder of the road and attract things like moose or deer that want salt. Mowing of the shoulder can then create new growth of vegetation that could attract wildlife as well. So you can have both of these changes in their normal behavior of being either repelled or attracted to roads. There can also be temporal changes in wildlife behavior. We've seen nesting birds change their timing and their habits in how they do nesting. Roosting bats also in and around roads can be affected by lighting and avoid those areas or change when they do their roosting. And then amphibian movements also have been seen to be affected when they make their movements related to roads. Here's just a little graphic showing an example of habitat loss. So the more road density you have, the less habitat you have available. I think that's pretty understandable. Additionally, this is just a little graph. Sorry, it's kind of blurry. But you can see related to noise for bird species, once it hits a certain decibel level, the density of birds diminishes quite a bit. So they're pretty sensitive and can't compete with that noise in their everyday life. And here's just an example of some mountain goats grazing on the side of a road, probably because a lot of water runs off the asphalt and then creates, more moist conditions for vegetation to grow. Additionally, some more impacts that can happen to wildlife is a barrier effect, and that is when you have reduced landscape connectivity for wildlife because of roads. And so when we talk about connectivity and corridors, those are places where wildlife have to move to access things to live. So food, water, mates, maybe migration. Wildlife, just like us, have to move to get to places and find their resources to survive. So construction of roads can often create barriers to those resources that they need. The results of that can be changes in wildlife distribution. So I'll have a little graphic later that shows how that can affect things. It also then results in direct mortality, right? Wildlife vehicle collisions cause death of animals, so that can create a barrier to movement just by animals physically not able to, cross a road. Over time, this can then create reduced population viability by disrupting rates of gene flow. They found in Banff National Park that grizzly bears were actually not able to cross the road, and it created two separate subpopulations on either side of the road that it took 30 years and multiple crossing structures to regain that connectivity. So it can have a really big effect over time. And so corridor function is something that can also then be impacted by roads. So where you may have a migration corridor, if you have a road that intersects that, that corridor may not be functioning then the way that it needs to for wildlife to continue in an area. And that provides, again, movement for dispersal and for plant and animal species. This is just a little graphic showing, individuals in a population and how they interact with each other. And then if you put a road in between them and it acts as a barrier, they may not have access to each other. So those individuals might not mate with each other. And again, you might have that differentiation in genetics and reduced populations. So the biggest, direct impact that we see from roads is wildlife vehicle collisions. And I can say as a person who's dealt with a lot of situations of having to, observe and report wildlife vehicle collisions, it's definitely very significant impact to wildlife. It's directly taking individuals out of a population. If, say, a pregnant deer gets hit, you're then taking multiple generations out of the population, right? So that individual wouldn't, have young that then go on to reproduce themselves. We also talk about roadkill hotspots, and what those are places where there's clustering of wildlife vehicle collisions. And to give you an example, our project area that we're going to talk more about, between 2002 and 2018, 33% of our collisions with wildlife occurred only on 7% of 395 in Mono County. So those are very small areas where lots of vehicle collisions are happening. And Dan's going to go over a lot more of that data in his talk. So obviously wildlife vehicle collisions don't just affect wildlife, they affect people as well. It's a big safety issue and it's a nationwide issue. There was a report that came out several years ago that estimated about 300,000 collisions with wildlife every year, but that's actually probably more like 1 to 2 million. The disparity in the data there is likely because a lot of collisions don't get reported. If there's a collision where the property damage is under $1,000, most people don't submit an insurance claim for that. So that goes unreported. Also, maybe drivers aren't in an area where they can report the collision because they're out of cell phone service or, again, there wasn't a lot of damage. Also, if people, are avoiding hitting an animal on the road and they swerve and it causes an accident, that doesn't always get recorded as, being related to wildlife either. There's also law enforcement entities and departments of transportation don't have a lot of databases to record this data as well. Unfortunately, our district, for Caltrans, we do have a really good roadkill database reporting system, which a lot of our data that Dan used and that we've used for this study came out of. And so I think we have data going all the way back to 2002. So we're lucky that we have that great data set to look at these issues and understand what's going on. Another reason why these collisions can often be underreported is because sometimes animals get hit by a car and then travel off the roadway and we don't end up finding their carcass, so we don't know if they didn't end up perishing or not because they go far from the road. So all of these things kind of lead to us realizing that majority of the data we have is way below what's actually happening out there. And in 2008, the Federal Highways released a report that accounted for about 5% of all reported motor vehicle collisions are with wildlife. And that's probably, again, a conservative estimate. Wildlife vehicle collisions are also expensive. There's a cost in terms of property damage And so there was a study again by FHWA in 2008 that found the cost of an average collision with wildlife is around $6,000. That includes, average property damage, human injuries, or human mortality. There's also an economic value to each animal that's hit. I think I saw a study where I think they estimated a grizzly bear is worth about $2 million just because of, all of the tourism they generate and people traveling from far to see them. They estimated, and again, this might be low, but for hunting and tourism for deer, each individual deer may be worth like $2,000. So when you put all those costs together, each collision, at least with deer, can be about $8,000, but actually when that was adjusted, it's more like $10,000 per collision. So a lot of people ask about if there's a cost-benefit analysis to doing wildlife crossing projects. Will it pay off in the end? And I think you'll see that that will be the case. So as I said, as sad of a subject this is, there's lots of solutions to how do we address these issues. So there's three main methods for addressing reducing collisions. So that's either influencing driver behavior, influencing animal behavior, or keeping animals off the roadway. Influencing driver behavior looks like installing roadway signs. I'm sure you're all familiar with the yellow crossing signs for deer or different animals that you see. Those have been found to not be very effective, especially for people who live in this area and pass that sign every day. It loses its effectiveness. There's also seasonal education and messaging that can be done through something like the center picture there, where you have a trailer that has a variable messaging sign that can only be put out at certain times of year. Those are a little bit more effective, but they don't necessarily reduce collisions. It increases driver awareness, but hasn't been really shown to reduce collisions. There's also animal detection systems, which are these systems that are a way to detect wildlife when they're on the road shoulder and then give a specific message to warn drivers that there's wildlife, next to the road. Those are a little bit more effective at reducing collisions, but there's still more research that has to be done. They don't work very well in areas where it snows, and there can be false positives that if something in the shoulder triggers it, and then you have drivers kind of worried that there's wildlife and there's not. So they have to do more research to see if that's effective. But those are all things to try and influence driver behavior, to alert them that there may be wildlife. And the main thing they can do is slow down, but doesn't necessarily mean it's going to reduce a collision. Influencing animal behavior is another method that's been researched. That can include reducing habitat adjacent to the road. So like we mentioned, if wildlife are sometimes attracted to the side of the road, if you remove that habitat, maybe that will reduce collisions. But that has some unforeseen effects where you might be increasing that road effect zone because you don't have any habitat there. So you're just increasing that area where it's affected by the road. There's also been studies looking at deterring wildlife from the roads, things like whistles, lights, reflective material. Those have also not been shown to be very effective at deterring wildlife from the roadway. So again, influencing animal behavior, not the most effective. Keeping animals off the road, however, has been proven to be the most effective, and that looks like placing crossing structures where wildlife can safely move under or over the roadway, especially when it's combined with wildlife exclusion fencing that funnels them to those structures so that they're not able to access the roadway. So these are some examples of types of wildlife crossings. The upper right corner there is in Banff National Park. That is an overpassing. So when we talk about overpasses, it's related to where the animals move. So this is where the wildlife move over the highway and drivers go under a bridge or a tunnel, as you can see there. Undercrossings, however, are like the two bottom pictures there, where wildlife cross under the roadway and cars travel above. Those can be bridges or usually culverts are what we use for those. These are most effective, again, when they combine wildlife fencing that is usually 8 to 10 feet tall, It covers the entire road length and funnels wildlife to those crossing structures so that they can't enter the roadway. So how do these work? As I mentioned, it's a full enclosure of the highway. You can see the diagram in the green there. You have wildlife fencing, and then maybe a combination of underpasses and overpasses. Another thing that can happen is at those fence ends, wildlife can sometimes get around them and then they can enter the roadway. So you have to have something called jump outs that then are one-way exits for wildlife to get off the roadway. So you can see that picture there with a deer's jumping over that, well, it looks like a fence. It's actually a ramp on one side and then a drop off. So they can jump down away from the highway, but they can't go the other direction. And again, are these effective? And what's the cost benefit? In Virginia, the Department of Transportation did a study there in 2018 that found fencing for just one underpass was effective to result in saving costs associated with deer vehicle collisions of about $500,000. And for Virginia, for them to build wildlife crossings is a lot cheaper than California, so that was, relatively a big savings to them. And they found that fencing was found to be cost effective if it prevented one deer crash per mile per year. So that's a pretty low bar to set for having those cost benefits. And again, these crossing structures and fencing reduce up to 90% of wildlife vehicle collisions. And I know we have some engineers in here, and they probably know that that's really hard to get to that level of effectiveness. So it's really a great solution that research has shown is really effective. So let's talk about our Mammoth project. So you guys probably recognize this area. It's literally down the road. It's so great that we get to do our talk here because it's literally right next to our project area. So some background on this project. In 2016, Mono County approached Caltrans and asked us if we could look into wildlife vehicle collisions. They'd been getting a lot of comments and complaints from residents and visitors noticing a lot of dead animals on the side of the road, and they basically wanted to know, is there an issue? What's going on? Where is the issue? What can we do about it? So we completed what's called a feasibility study report, which took all of our roadkill data and identified where in Mono County we had an issue with wildlife vehicle collisions. Well, we definitely identified the highest priority location, and I'll show you a map in a second, but it was basically this stretch of 395 just south of Mammoth Lakes. So once that was completed, we handed that over to the county, and we actually started an Eastern Sierra Wildlife Stewardship Team. I'll show a slide for that in a minute too. We've grown over time and have lots of great support and many different, nonprofits and local organizations. And so we have definitely a lot of support from the beginning for this project. In 2020, Caltrans funded what's called the scoping phase of this project. I'll try to minimize the amount of Caltrans jargon that I use because I know there's a lot, and so I'll keep it to a minimum. But we completed something called a project study report, which is a PSR, or a project initiation document, a PID. And basically what that document has in it is the cost of the project estimated, the scope of the project, and some minimal design, and then the schedule. How long would it take to build this project? So those documents are really our template and blueprint for how we move forward with starting a project. So we completed that in June 2020, and so that was a good first step moving towards this project. But unfortunately, Caltrans doesn't have necessarily any dedicated funding just to construct projects for wildlife connectivity. So we kind of got stalled out after that scoping phase. And there's various other phases that have to be completed to actually get to construction. So there's our PA&ED phase, that's our project approval and environmental document phase, where we actually complete an environmental document that looks at potential impacts that the project could have and what those are. We then have our PS&E phase, which is plan specifications and estimates, and that's where we complete all of our design work. and then everything actually goes to construction. So there's quite a few steps that have to happen before we can actually go to construction, and that all takes time and funding and staff support. We also identified in that scoping document that we would have to complete a CEQA NEPA document because we do have quite a few cultural resources in the project area. We have biological resources that would be affected, like wetlands and waterways. And there's also some visual resources. You know, this is a scenic highway. We have to account for that. So because of that, we do have to complete that level of environmental document. Fortunately, we also had a CDFW graduate thesis project that Dan completed, and he'll go over that. But that really helped move the project forward as well, because it took all of that data and really gave some good guidance into how and why we need to do this project. There is also some grant funding that's been available. Obviously, wildlife crossing projects are very popular now. You see them in the news a lot, and so there's been a lot more funding available through grants, and I'll talk about that in a minute, but the Wildlife Conservation Board has a grant through Proposition 68 that provides funding for wildlife crossing projects. So, we had a tough time for a little while. We didn't have any identified funding. We knew we had to do this project, but we were trying to find ways to move the project forward. So here's just a crude map of where the project area is. Again, through our feasibility study report, we identified this as the #1 area in Mono County to address wildlife vehicle collisions. We have 4 of the top 5 roadkill hotspots in this one stretch of highway. The 5th one is north of Bridgeport at Buckeye Road, and probably there's even more, I think, that Dan has identified as well. So, but this is definitely the area where most wildlife vehicle collisions occur. So I also want everyone to be aware of that while you're driving. There's lots of wildlife out there. Be aware. These are just some logos of some of the folks on our Eastern Sierra Wildlife Stewardship team. Again, we've had really, really great support from all of the different agencies in our area and elsewhere. You know, Defenders of Wildlife, Eastern Sierra Land Trust is our #1 champion nonprofit that's been, cheering us along this whole time and been super involved in all of our work. CDFW's been a great partner as well, bringing a lot of science into what we do. Mono County, of course, has been, really, really helpful with this, and other groups like California Deer Association have helped to try and raise funding for deer fencing and things like that. So we have a lot of great partners that have come out of this. So that feasibility study report also resulted in 5 different alternatives to addressing wildlife vehicle collisions in this project area, and I'll just kind of go through them kind of quickly, just so you can get an idea of what it would take to address this issue. So this is concept 1. This is the one that covers the entire project area. It is the most expensive. We also nicknamed this the whole enchilada because it, is kind of covering everything that we, need to address in the project area. So this concept includes 18 miles of fencing on Highway 395 and 203. We would install 4 new crossing structures on 395 and 1 new structure on 203. And Mammoth Creek, we would also do some improvements there because we have a bridge that's already existing there, and wildlife do use it, but we would do some, vegetation management, get fencing connected to it so that it can be more of a funnel for wildlife to use that. The price there, that $53 million, is decently accurate, but that's just the cost for construction. So again, those other phases that have to happen to get to construction, there's still funding that's needed for those, but the price tag for construction is about $53 to $60 million. This is concept 2. This just addresses 395 only, not the section of 203. This would include 13 miles of fencing on just 395. Again, 4 new crossing structures and those improvements to the Mammoth Creek bridge. That one's a little less expensive at $41.6 million, but still a pretty big price tag. Concept 3 is a little different than concept 2. I think we swap out a undercrossing or an overcrossing for an undercrossing. It still has 13 miles of fencing on 395 with 4 new structures and those improvements to the Mammoth Creek Bridge. Concept 4 is just the northern portion of the project. That would include 8 miles of fencing just on 395 and 2 new crossing structures and those improvements to the Mammoth Creek Bridge. So that would be just from the Mammoth Airport north to the 203 junction. And then concept 5 is the southern portion only of the project area. That would just be from the airport south. That would be 7 miles of fencing on 395 and 2 new crossing structures. However, this would address our worst roadkill hotspot that we have, which is actually right there at the Benton Crossing Road. So again, just so people are aware. But this one is less expensive at about $18 million. So as I mentioned, we've struggled a lot with getting funding for this project. We approached the Wildlife Conservation Board. They have a grant program, as I mentioned, through Proposition 68. And we tried multiple times to get funding from them. In 2019, we applied and we were requested to submit a full proposal, which means you're usually in the running to potentially get funding. We requested about $3.3 million, and that was going to cover those 2 phases that would need to be completed before construction. So we estimated that would be about the amount of money that is needed to do everything we need to before we get to construction. Unfortunately, we're unsuccessful in that round of funding. Since we have to do a lot of work before we can go to construction, it was less competitive than a lot of other projects that maybe had all of those phases done, and we're just waiting for money to go to construction. In 2020, we applied again. We submitted just a pre-application, but we were not requested to submit a full proposal. So that time, we asked for about $2.9 million to try and reduce the amount of funding we were asking for, and that was going to be just for one of those additional phases before construction for that concept 1, the whole enchilada. We were again unsuccessful at that time. So 3rd time's a charm. In 2021, we applied again. We really tried to strategize how we requested funding and tried to minimize the amount of money we were asking for, thinking we'd be more competitive. So we asked for just under $1 million just for that concept 5. So that concept 5 was just the southern portion of the project area, just to complete, the environmental document for that. And we figured, it's under $1 million. It's just focusing on the environmental document for the core, the worst area that we have. And we were approved. So we were super excited, to get to move forward with some funding. So on December 20th, 2021, the Wildlife Conservation Board voted to confirm our funds, which was very exciting for all of us. And so we were moving forward with, okay, we're going to do the environmental document for Concept 5. This is great. We had the Wildlife Conservation Board grant coordinator come out and do a field visit with us, and that was in July 2022. While we're in the field, he turned to me and said, we have a lot of money this year. You should maybe just ask for more money. And so all of my strategizing of, reducing costs, he's like, no, forget that. Just ask for more money. So I very quickly, I think it took me like 2 weeks, I put together a new proposal, a new budget to ask for $2.8 million to complete the environmental document for that concept 1, back to the whole project area, which really makes more sense because if you're doing an environmental document, you might as well just do it for the entire area, even if you end up building things in sections. So we submitted that proposal, and then in November 2022, the board met again and they confirmed our funds, and we even got a little bit more. We got a little bonus. We got $3.17 million. So yeah. Yeah, yes, yeah. Yes, WCB, good job. So this past spring, we have already started some of our surveys for the environmental document. If you drive through and you see people in hard hats, that's us out there, collecting data for our environmental document. We've got, again, lots of partners helping us with that portion of the project. We're continuing to work with our Eastern Sierra Wildlife Stewardship team to find additional funds, whether that be private funding or more grants for those future phases so we can get to that construction point. Future funding, there's been a lot of legislation that has also been passed, things like SB 790, which is looking at potentially having wildlife crossings be advanced mitigation. So that could be a source of funding as well. So we're really hopeful that, this project can move forward, and it's so great to see all of you here. And if you guys can, continue and support this project, that makes a huge difference when we do go to get funding, especially through grants, having the support of our community. So I'm sure Kay will talk more about that, but yeah, it's really great to have all of you here and online. And with that, I'm done. So, yeah.
Everyone hear me okay now? Cool. So as Katie said, I am Dan Taylor. I am the Inyo and Mono County Wildlife Unit Biologist for the California Department of Fish and Wildlife. I also just recently completed my master's research at Utah State University, and that's what I'm here to talk to all of you about. And my research consisted of quantifying the impacts and assessing the permeability of a divided 4-lane highway on migratory mule deer. So Mono County is made up of 5 mule deer herds that annually migrate to summer range habitat in the eastern Sierra Nevadas from winter range, primarily located in western Nevada and eastern California. So all of these herds, like I said, annually cross in the spring and fall when migrating to that summer range. But we're focused on the lower section down here in the Mammoth Wildlife Crossing Project, and that is crossed primarily by the Round Valley herd.
Just gonna get this on. Sorry about that. Slight technical. Stop share, and then I'll redo your share. Sorry for the technical difficulties here. There we go. You are screen sharing.
Okay.
But we were not seeing it here.
There we go.
I think we're good. Is that good? Okay.
Alrighty. So like I said, the Mammoth Wildlife Crossing Project is primarily crossed by the Round Valley herd. They winter down near Bishop in that area called Round Valley. I'm sure many of you have seen it on your way up here. It's just west of Sherwin Grade there as you're going up the hill. And it can be crossed by the Casa Diablo herd as well, although from this study, we identified that most of those crossings tend to occur north of our project area. In 2019, we put on 42 collars in the Casa Diablo and Round Valley herds to determine if any of these animals would cross. So these deer were collared on the winter range with high fixed rate GPS collars that recorded a location at every hour of the day. And so that way it provided us very fine scale data of where these animals were taking those migration pathways and then where they were crossing the highway. So as you can see in this picture, the Round Valley herd are very susceptible to the highway because they migrate along that eastern escarpment of the Sierras and essentially bounce back and forth between US 395 and the Sierras. So they are very much bottlenecked by the highway in that section, and this causes this area to have the most number of deer vehicle collisions within Mono County, as Katie recently suggested. Our study area consists of the section that Katie described, just occurring just south of the airport and then extending up 203 and just past the 203 junction. We also had a control area to test if any lack of, highway crossing signs like deer vehicle signs or deer present signs, stuff like that, would influence driver behavior. So our control area we chose was just immediately south of the project area because it had similar habitat to the project area, was adjacent to the Round Valley herd migration corridor, and also just had a lot of the same terrain features that were in the project area. So we were testing this area to see if deer crossed as frequently here as they do further north. So the objectives of our study were to identify unsuccessful crossing hotspots within the project area using standardized roadside carcass counts, and then identify successful highway crossings within the project area using those high fixed rate GPS collars that I talked about. And then we evaluate the spatial relationship between these unsuccessful and successful crossings to see if they occur in the same location. So the null hypothesis is the one that essentially we're trying to disprove, is that deer vehicle collisions occur randomly throughout the project area, meaning that there's no significant hotspots and that deer can be hit at any similar location with equal odds throughout the whole project area. And then the hypothesis is that deer vehicle collision rates are driven by the relative intensity of deer crossings, meaning that where deer cross the highway is also where they are hit with the highest frequency. So to test this, we conducted the deer vehicle collision surveys between the spring and fall seasons, essentially. And that would consist of doing a driving survey, starting approximately about 1/2 hour after sunrise, where we would drive slowly along the shoulder and record any wildlife species that we came to that was involved in a wildlife vehicle collision. We would then we would record location, the species, the sex and age, and details of any marks, as like if it was a colored animal in the bottom left corner there. We would then mark the carcass with orange paint and remove it from the shoulder to avoid duplicate counts in the future. So we conducted these surveys between April and November, so basically starting in the spring migration, going all the way through to the fall migration to account for any summer resident holdovers that may be occupying the area throughout those summer months as well. And during that time period, we conducted 364 surveys in 2019 and 2020, where we recorded 157 wildlife vehicle collisions in the project area or in the study area, and 24 wildlife vehicle collisions in the control area. This represented 23 different species in total, of which mule deer accounted for 70%, meaning that mule deer should be the priority species for wildlife crossings within this project area. For our GPS telemetry study, as I said, we fit 42 mule deer with high fixed rate GPS collars on the winter range, and only 10 of those animals actually crossed the project area within our study area during their seasonal migration. We had a number of animals migrate through adjacent to the highway, but they never actually crossed the highway, so we did not include them in this study. As you can see here, we had a number of deer from that sample. The majority of it actually were summer residents that maintained in Long Valley, so the area around the Mammoth Wildlife Crossing Project, throughout the summer months, and continued to cross the highway that whole time, while other deer continued to migrate through the project area after the snow melted out at higher elevations and allowed them to access that area. To analyze this, we created essentially a spatial polygon data frame, which corresponded to 1/10 of a mile post miles along the highway segment. So essentially, each of these segments there that you can see is 1/10 of a mile. And we chose that because that's currently the finest scale of measurement that Caltrans has for recording wildlife vehicle collisions. And so that was what would be the best way to estimate it. We then used the software optimized hotspot analysis using ArcGIS Pro software, and that conducts a spatial autocorrelation test where it essentially counts the deer vehicle collisions that occur within each segment and then assigns it a spatial weight relative to other segments with high numbers of DVCs or low numbers of DVCs. So essentially, if you look at the bottom right corner, if there's segments of DVCs or segments with high numbers of DVCs located next to other segments of high numbers of DVCs, then that would be considered a statistically significant hotspot. And vice versa, if it's low numbers of DVCs spatially located to segments with low numbers of DVCs, that would be considered a cold spot. So, and then anything else that's kind of in between that would be just considered random. So when conducting that analysis, we identified 3 statistically significant hotspots within our project area. The first and most significant one, which Katie mentioned earlier, is the Morrison Hill hotspot, which occurs just here at the end of the road, as most of you know. And that one accounted for 33% of all the DVCs that we recorded during this study. The next hotspot that was the second longest in length, although deemed less significant than the previous one, occurs just at the northern end of the airport here. And then the third statistically significant hotspot occurs right near Mammoth Creek. So these hotspots are all basically a high, what we call a Z-score, and that's calculated from that spatial weight and the aggregate count of deer vehicle collisions. And it's assigned a p-value to calculate the statistical significance. So these are the segments that are statistically significant. But what's cool about this software is that we can examine those Z-scores and essentially identify warm spots as well. So as you can see, the 3 most darkly colored spots are those statistically significant spots, but there's also warm spots occurring essentially from the north end of the airport all the way to the 203 junction. So what does this mean for our null hypothesis? This means that we should reject it, right? Because there are statistically significant hotspots occurring within the project area, meaning that it's not occurring at random. And so to analyze the successful crossing locations, we use what's called an exponential resource selection function. And this is a program, we conduct this in a program called R. And essentially what this method is used for in most wildlife is identifying habitats that animals will select for when going about their daily life. So if it's water resources that animal would select for a specific habitat, that's what this method is usually used for. However, the resource that we were selecting for this study was a successful crossing location. So essentially, we were trying to identify the predictor variables or the habitat variables that would cause a deer to select for a specific point of the highway to cross versus other areas. So the predictor variables that we examined were a vegetation layer consisting of riparian corridors that extend across the highway, sagebrush, and forest, because there is a small amount of Jeffrey pine forest occurring at the north end of the project there on US 395 and in 203. And then terrain ruggedness, if topographical features have an influence on where deer cross the highway, as well as a vector layer of ridge lines that extend across the highway, because all the literature out there basically points to that ridge lines, riparian corridors, major topographical features essentially act as funnels for wildlife movement, because it's just they follow the path of least resistance for the most part. And so those terrain features can essentially funnel deer across a highway. Oh, and then we also looked at the migration status of the deer, because obviously we can't analyze the deer that were only there for a short part of the year the same way that we analyze the deer that maintained throughout the whole year, just because they were crossing at different intervals throughout different times of the year and with different frequency. There we go. I won't go too much into the equation that I used to analyze the data. I had to explain all this like a couple weeks ago in my defense, but luckily here I'm just going to explain that it was a binomial generalized linear mixed model and leave it at that. So essentially our top model, we found that in like what we've seen from literature, was similar to here. Basically the predictor variables that had the largest influence on mule deer crossing the highway were riparian corridors and ridge lines. And so our top model examined those predictor variables in relation to migrants, and our second highest model just didn't examine that relationship. And what that produced with this chart on the side here is essentially the log RSS values are the likelihood. So basically these the riparians and the residents were twice as likely to cross the highway if it was associated with a riparian corridor. Similarly, they were 1.2 times as likely to cross the highway if there was a ridge line extending across the highway there. When we analyzed it for our migrant data, it was interesting because it almost had the opposite effect. The migrants show that they're almost 2 times less likely to cross the highway in a riparian corridor, and ridge lines just really didn't seem to have an effect at all. But we can attribute this to just essentially not having enough crossings by migrants. We had 245 crossings from summer residents. No, sorry, 256, I should count better. And then 12 crossings from summer residents, from the migrants. So essentially we had over 230 more crossings attributed to these summer residents, and we just didn't have enough from those migrants to accurately model where they would cross. But from our results for the summer residents, we identified 5 major crossing locations that deer seem to frequently cross the highway more often than other places in our study area. The first, starting from the south end here, was what we'd call the McGee Creek crossing. This occurred actually in our control area, and what's interesting about this is it was actually identified as a statistically significant cold spot in our hotspot analysis. So this, it doesn't really jive with that hypothesis that deer vehicle collisions are also driven by where they cross with the highest regularity. And we can attribute to these successful crossings or speculate that the reason that DVCs occurred less in this section was it was just flatter topography. There was not as much habitat adjacent to the roadway blocking visuals from both deer and motorists, and there's just no turns or bends as much in the highway that really caused that visual capability to decrease for both motorists and deer. The second crossing, 2 crossings occurred essentially on Morrison Hill. I split them up here for the purposes of the project, just because they technically aren't the same, but they occurred within a half-mile segment of each other. So that occurred essentially on Convict Creek and just on the south side of Morrison Hill there. That's also, if you remember, where our most statistically significant hotspot was. We had 1 crossing that we identified which occurred in the middle of the airport, and then one that occurred near Hot Creek for the summer residents. For our migrant predictions, it was relatively the same. All those previously identified crossings are still there, although bigger, but the migrant predictions also identified a crossing by Mammoth Creek and a crossing by the north end of the airport. And, while we had limited crossings from those migrants to accurately model where the predictor variables would influence a crossing event, it was still enough to essentially give us data points on where they were more likely to cross the highway versus other sections of the highway. So when we compare these predictions, we just did based off the values of where deer were hit versus where they crossed, essentially. And we actually had very low correlation. So this was surprising, and that the resident predictions had a very low correlation with the DVC count. And it actually was deemed to be not statistically significant. Similarly, with the migrant prediction, it was a little bit better, but still not statistically significant. But when we compare that to the Z-score, so that's the results from our hotspot analysis, it increased the correlation. And so we speculate that this is because that hotspot analysis essentially smooths out where these segments are being recorded to have DVC hotspots. So if there's a gap in those segments, the spatial correlation test will basically account for that distance between there and determine if it is still a high chance of a deer being hit within that segment. However, so what this means for our hypothesis is that we essentially can't accept it because the DVC, there is such a low correlation between where these deer are getting hit and where our sample of deer were being crossed. So in regard to that, it means we should fail to reject the hypothesis. So just looking a little bit closer at, where these deer are crossing and trying to determine, what influenced those crossings. Like I said before, this is the McGee Creek crossing that occurred within the control area. This was our only crossing to be identified within the control area which occurred in that cold spot, like I mentioned earlier. Like I said before, this is likely that area just did not have, the same kind of terrain features or vegetation that was similar to other parts of the habitat that experienced higher numbers of deer vehicle collisions. So the deer were just likely able to cross there more successfully based off those features. And when looking at the hot spots at the south end of the project, like I said, the Morrison Hill hotspot is our most significant, and this also encompasses 2 crossings that we identified: the South Morrison Hill crossing and the Convict Creek crossings for both the migrants and the residents. So this area should be prioritized as the main concern for the Mammoth Wildlife Crossing Project in terms of management implications. And the reasons that these deer get hit there and cross there is that there's this large moraine that extends across the highway. I mean, you all drove up it, you all have seen it. And as I was talking about before about deer using those terrain features to funnel movement, when they migrate up from their winter range, this is the first terrain feature that really extends across their migration pathway when they get to Long Valley. And it really causes them to just funnel across the highway here between that ridge line and the Convict Creek, because, both of those terrain features influence crossing, so them being so closely adjacent to each other causes this section of highway to account for the most DVCs within the project area. Similarly, there's also guardrails, increased vegetation, and a curved alignment to the road, which increases or reduces sight visibility for both motorists and deer, which also has been shown to contribute to high numbers of DVCs. When we go a little bit further north towards the airport, once again, we can kind of see that we had a successful crossing identified where we had a cold spot, essentially, in the kind of southern end of the airport there. And this was a crossing that was identified for both migrants and residents. And, when you look at this, it's like, well, why would these deer cross within this section of development where there's, essentially it's all cut off on one side? And that was a question I was really looking at. So when you look at the GPS tracks of where these deer were crossing the highway, there's actually a gap there between the hangars of the Mammoth Airport, where it's essentially just a meadow system, and it was an opening for these deer to make it across the highway. And it actually served as a funnel, essentially, for this area to become a crossing location. And then moving a little bit further north on that North Airport hotspot that I mentioned earlier, that was identified as a successful crossing. And when looking at terrain features that may influence a crossing in this area, there's no ridge lines or riparian corridors that would account for a crossing, but there is the Mammoth Industrial Park, which I'm sure most of you know has a built-up berm along that kind of south end of the park. And so any deer that are moving adjacent to the highway hit that, and just the natural way it funnels towards the highway is just an angle that the deer will just naturally follow and be funneled into oncoming traffic, which is why there is such a large hotspot and statistically significant hotspot there at the north end of the airport. And then our last hotspot is the Mammoth Creek hotspot. This is an area where I'm sure you've seen all those poles going up. If you've driven through there at any point recently, that's after working with Katie and BLM, who provided the fencing, because luckily there's already a crossing there at Mammoth Creek that could be developed. So that's something we can already work on to try and reduce the collisions that occur here. And the reasons that those collisions occur is essentially there's two meadow systems occurring right on either side of the highway there. And, this is high quality habitat for mule deer. There's nutrient-rich forage in both those meadow systems. And there's also terrain features. They're somewhat hard to tell here in the photo, but there's a rocky outcropping occurring here and a small ridge line that extends across the highway here. And so, like I said previously, and it's kind of beating a dead horse with it, ridge lines and riparian are essentially terrain features that funnel movement. So it will just continue to funnel movement in these areas where deer will cross the highway and continue to get hit, like right here at Mammoth Creek. But fortunately, there is also that Mammoth wildlife crossing or undercrossing there at Mammoth Creek. So it would be very easy to just build that and extend the fencing outward and to have deer go through that already existing crossing. So once again, back to my hypothesis that deer vehicle collision rates are driven by the relative intensity of deer crossings. Given that low correlation, like I said before, it's it could be that we had a low sample in terms of the number of deer that actually cross the highway, and ways that we can mitigate that in the future would potentially be to collar deer actively on next to the project area versus on the winter range, so we could get a more accurate number of deer crossing the highway. However, based off the information in this study, we failed to reject the hypothesis that deer vehicle collision rates are driven by their crossings. So it is possible that deer are crossing in areas successfully where they're areas where they're not getting hit. When applying this to management implications and thinking about those 5 concepts that Katie introduced before, from looking at our data and our results, we essentially recommend that Caltrans should adopt concept 2 from a cost feasibility standpoint. And the reason we talk about this is the 2 crossings here, the north end of the project that would be installed, those would mitigate the most statistically significant hotspot. And the 2 crossings that would be put north of the airport work to actively mitigate the hotspots between near Mammoth Creek and the hotspot occurring just north of the airport. While it would be great to put a crossing in the middle of the airport, it just obviously isn't feasible. So we have to work with what we got. So this is the existing crossing there on Mammoth Creek, which, like I said before, is already pretty much there. All we need to do is just build fencing to it. The reason we decided not to go for concept 1, which was the whole enchilada, as Katie described it, was that we really did not find it justifiable to put an overpass on 203, because during our study, we only observed 2 deer vehicle collisions on this section of highway and had 3 crossing events from 1 migrant deer. So essentially, just based off the overall data, this area experiences a lot less crossings, I should say, and a lot less DVCs than the rest of the project area. So our money should focus on mitigating these more intense areas prior to building a very expensive overpass on 203 if it's not going to be that beneficial to many animals. And then those crossings, again, in terms of where the deer cross the highway, the 2 wildlife crossings down at Morrison Hill will work to mitigate the crossings identified north of the airport there along Morrison Hill. And the fencing along just south of there should extend far enough south that we should not have to worry that it should encompass that McGee Creek crossing as well. So that it'll funnel those deer to that crossing structure as well, and it should mitigate all those. Similar to the north end of the airport, crossing structures there with associated fencing should mitigate DVCs and increase habitat connectivity. Like I said, it would be great to keep those crossings along the airport, but it's just not feasible. So we'll just have to route them around with fencing, and then eventually, the airport's a tricky situation because typically you're not supposed to have crossings over a mile apart, but because you don't want to be moving deer that far out of their migration pathways. However, given the circumstances, it's kind of what we have to work with. And Katie and I have been brainstorming different possibilities for jump outs on the roadside adjacent to the airport there that will hopefully, if deer are caught in the roadway, will still be able to get out, even though there's not going to be a crossing structure there. And so what this means for management implications is, of course, we still have to do monitoring to see the effectiveness of these crossing structures. But if, based off the research out there and the effectiveness that have been documented, by implementation of these crossing structures, it will help to reduce wildlife vehicle collisions within the project area, reestablish or maintain habitat connectivity and permeability across the highway, and continuing monitoring will just continue to provide Caltrans with wildlife crossing data for future projects in Mono County. Before I go, I would just like to acknowledge my advisory committee, Mary Connor, Tom Stevenson, and Tal Avgar, as well as the folks from California Department of Fish and Wildlife, Kathleen Anderson, Dave German, Tim Taylor, and Mike Brown. And then finally, Caltrans, Katie Rodriguez, Stephen Filer, and Jonathan Fusaro. Thank you all for listening to my research. I hope I didn't butcher it too bad, but I will pass it over to Kay now.
Well, thank you very much. Thank you very much. Katie and Dan, you guys are amazing. And I'm just going to talk briefly about Eastern Sierra Land Trust, why this project, a couple of reasons why this project is so important to us, identifying some future funding, and how you can help. So Eastern Sierra Land Trust was founded when a couple visionary folks started noticing that in Swall Meadows, there was an expanding development coming in right in the middle of the migration corridor. On one side, there's the Sierra, on the other, the gorge. Oh, and by the way, there's 395, and there were houses. So they looked to see, was there a tool that could help people home protect the migration corridor? And we have two of those founders here in the audience tonight. I don't think I need these glasses. I wanted, Tony Taylor was a founding board member, and Rick Cattleman back here was also a founding member of Eastern Sierra Land Trust. So we have them to really thank for this going. Here is just what our mission is that came from this group of visionaries getting together to identify solutions to the project, to the problems. So what has evolved from there is this. We're Eastern Sierra Land Trust. We are based in Bishop. We have about a $1.4 million operating budget this time. We work in 9% of the state of California, plus Western Nevada. We have 8 board members. Tim is also here with us tonight, plus the Rick and Tony, who's a board member emeritus. We have a large crew now. We're up to almost 10 by the time we put our bookkeeper in. We have 8 vetting working committees, and we are accredited. It's a national organization called the Land Trust Alliance, and it's an incredibly rigorous process. You can ask Rick about it. He was on the team. We have been accredited 3 original accreditation 2011, renewal in 2016, renewal in 2022, and it means that we uphold the highest standards of all of our practices and procedures and how we work with our communities. So this is just if you have any questions, I'd be glad to talk to you later. We really want to focus on the migration corridor, but we get a lot of questions. Why is a land trust working on a migration corridor? And it's because we work with the land, we work with willing landowners, we protect it from future development with working with willing landowners. We purchase their development rights in the case of a conservation easement. Sometimes they donate it, sometimes they donate land, sometimes we purchase land. Sometimes there's all kinds of real estate transactions that that form how we do our work. This is just a quick map of where our projects are. We have over 21,000 acres permanently protected in Mono County. We have a community program where we can get out on the land. This is where we teach. We also have the sunflower kids, as you can see. They come over and we teach them how to. It's okay to get your hands in the dirt and the bugs. And we also, you can see in this picture, we take kids out to Black Lake or Benton Hot Springs Conservation Easement and teach them how to use binoculars and get out there. And some of these kids, it's actually the first time they're out in nature. Hard to believe in our community, but it's the case. And one of the things we do is our mule deer migration corridor field trip. We try to do it every spring. We've been kind of snowed out this year and last year. And Katie and Dan and Dan's predecessor, his father, Tim, have been instrumental in helping us with this field trip. And if you're ever interested, we hosted in Round Valley where, as Tim was, sorry about that, Dan was saying, the mule deer, the Round Valley mule deer, they go up to the higher elevation, back down, which is, again, why the migration corridor through SWAL is so critically important. We also do volunteer restoration and stewardship days. We're hoping to do some volunteer work out here at some of the crossings. So if you're interested, I'll show you how you can sign up to get notice of those events. Another project that we at ESLT work on is wildlife. Obviously, habitat and migration corridor protection, as well as bi-state sage-grouse, are several of our highest priorities. This leads us to the crossing, and you can just tell why this is so important. ESLT was founded on protecting the migration corridor. It's natural that we want to help protect these animals as they move across so often, not even just twice a year anymore, is what Dan helped me understand. And again, as Katie said, $3.17 million was recently approved from the Wildlife Conservation Board, which is a state agency through California Natural Resources Agency. That ties into the governor's initiative. You've probably heard of it. It's called 30 by 30. The goal is to conserve 30% of California land and coastal waters by the year 2030. This website here, CaliforniaNatureCA.gov, you can check it out. There's interactive maps. You can see the status of the lands and water that are currently protected, and you can see lands that are being protected. In my lifetime, I've never seen an opportunity for large-scale conservation and wildlife protection. Often there's an initiative that comes out, but there's no funding. This time, there's an initiative, there's funding, and oh, by the way, instead of just normal conservation, woven through 30 by 30 is one of the core values is to advance justice, equity, diversity, and inclusion, strengthen tribal partnerships, and sustain our economic prosperity through clean energy and food supply. So this is really I think, a once-in-a-lifetime opportunity to weave conservation, funding, and access. And I'm going to lose my voice here. And another thing with 30 by 30 is, hopefully you can see it. You can see where we are right now. The latest report just came out. I'm so sorry. And anyway, you can see up there. I'm not going to tell you what you can see. I do want to say that part of 30 by 30, a core value, is connectivity and biodiversity and migration corridors. So this project is queued up at the exact right time to get further funding as we're ready for these next steps. It's divine intervention, actually, that we... Oh, thank you so much. I so appreciate that. Very kind. Thank you. So we have identified some future funding once we can get a little bit farther, but this is time for where you can step in. We have a website, and you can sign up on the website. You can also make a donation, and it is restricted to this project. So any funds that you make through the website for the wildlife crossing stays for the wildlife crossing and will be used for future projects or future phases of our project. And I believe, there is a QR. If you want to come get it off the computer later, you can scan that and it'll take you right to the website. If you've got any questions, we'll be here afterwards. And Katie, I think I'm going to hand it over. Thank you.
Okay. I think we were just going to go to questions. Let me try and... Yeah.
And we'll pull up a Q&A here. So,
Oh, yeah, people online, for sure.
there's people online. Can you guys hear me through this one? Try this one.
Oh, because I have this on.
Yeah. Okay, so what we'll do is raise your hand, and maybe if I have Annie, would you be willing to walk around with the mic? So just if you have a question, raise your hand. Annie will bring the mic over, and that way we can have the folks on the Zoom hear your questions. And then we've also got some questions from the Zoom folks online. And it, that's Mike. Who's Mike 2? Maybe turn yours off and then.
Hi. I'd like to sing a song for you right now.
The poles along 395 were briefly mentioned in one of your presentations. I've noticed them. They're basically north of the airport. What is that all about? What do they do? Is it even related to wildlife?
Yeah, so those poles were put in last spring, and those are what are going to hold up the wildlife exclusion fencing to that Mammoth crossing, that Mammoth Creek crossing. So that's the one that we were able to already put fencing on because, there's already an established undercrossing going under the road there. So that fencing was just put up as kind of like the poles were put up to test to see how the winter affected them. And then the plan is to put fencing on that before this next migration.
Yeah, BLM was able to receive funding to purchase the fencing material. Yes.
Oh, that does work. Okay.
Yeah, their BLM got funding to purchase fencing materials, and so we worked with our maintenance staff to install the posts, which was very challenging actually because we had to drill through some lava rock, which was not anticipated. But we knew that we wanted to see how the posts would hold up, like Dan said, over the winter, and then we're going to assess with them when we could install that fencing, so that at least we could have that section around the Mammoth Creek Bridge fenced so that wildlife will not enter the road there and they'll use the bridge. So we'll see how that goes.
This is a question for Katie. Have you worked with Nevada DOT because they have some wonderful wildlife crossings, especially as you go north? Through Wells, take a left, whatever. I think that's 6. And I wondered if you have any data from there and photos, because that brings it home that we may need to do more.
Mm-hmm. Yeah,
because
absolutely.
they have been doing it.
Yes, yeah. Actually, a good friend of mine, Nova Simpson, is a biologist for the Nevada Department of Transportation, and yeah, she's been doing a great job. I think they've installed something like 10 crossings in 5 years, so they've been very successful at that. So I regularly talk to her about advice or learning from her projects, what was successful, what wasn't, if she has any design plans that we could use. How do you deal with wild horses is something they've dealt with in Nevada, and we have here as well. So yes, definitely Nevada DOT folks are a great resource for us, and we have lots to share and learn from them.
We also have some questions online.
Oh yes. I see a friend of mine, Lindsay. Tell Katie she's awesome. Oh, thank you, Lindsay. Let's see, Claire Marvin.
A staff member is
Yes, at ESLT. Why does an overcrossing? I have missed this. I came in late, but is there a benefit to overcrossings versus undercrossings? Thank you for your work. Thank you. It's kind of going in and out. So concept 5, that was the southern section of the project area. In that area, we would be placing a bridge where Convict Creek is, and then an undercrossing a little bit south of Morrison Hill. We chose to do undercrossings there because of the topography, also because undercrossings are less expensive and this have about the same effectiveness. North of the airport, we would have an overcrossing for the same reason. The topography there is very flat. The groundwater level is really high. There's not really available space to dig under the highway. So there are different benefits to having over/under crossings. More species use overcrossings, especially bigger ungulate species like elk and mountain lions. But for our target species for this project is mostly mule deer. And so we are going to design the structures, specific to them, but it will benefit many other species as well, like black bear, mountain lion, smaller animals like mesocarnivores, skunks, raccoons, things like that. So, for us, for this project, a lot of the choosing of the types of structure was based on the topography and some of those constraints.
Related to the fencing comment, I had the pleasure of traversing the Trans-Canada Highway in Banff this winter.
Nice.
The overcrossings are beautiful. I definitely recommend the area to anybody. It's a little different. The high fencing is about 100 feet from the highway, and beyond that is extremely dense forest. You can see the mountains, but the fence is not as noticeable. I could anticipate, and I'm sure the studies and the group has anticipated some possibly NIMBY comments regarding fencing along 295. I think it's about 15 miles of fencing if my conversion from metric worked well.
People online can't hear.
Oh, people online can't hear me. Oh my goodness. Regarding the fencing, I will not repeat the whole question. Thank you. Yes, beautiful overcrossings and fencing in Banff, less noticeable with the dense forest there. How does it work here along the 395 corridor with what we have are definitely stellar views, but obviously some concerns.
Yeah, definitely. And that's where, if you remember in my presentation, we mentioned those visual resources. So it is a scenic highway. So we do have to account for how, our project could impact those view sheds. The overcrossing, even though is, really functional and a lot of people like that, it would obscure some views while you're driving. So we have to take that into account. And then, yes, the fencing also could have some visual impacts to drivers and the quality of, the scenic highway. We can do some mitigation measures to try and minimize that. So there's something, if you notice on a lot of our guardrail on 395, it's not that shiny chrome silver. We apply something called natina. That's a stain that then tries to blend in with the natural environment, and we pick the color that's usually, something in the color palette of the surrounding habitat. So we did talk about the fencing being coated with, that natina spray to try and not, have this shiny silver fence. I believe the posts that we would do the same thing if they were metal. I think we are probably going to prefer metal posts due to fire hazard versus wooden posts. And then the overcrossing, there's things we can do like stamped concrete or all kinds of different visual, mitigation measures to try and, as best we can, blend that into the background. I think somebody suggested a mural underneath when you're driving through, which could be really cool. But yes, we definitely will be evaluating that in our environmental document, which, of course, when that gets completed and is a draft available, that's open for public comment. So we'd be happy to have people comment on, how they think that will affect the visual resources.
Awesome. Thank you.
Yeah, thanks.
Thank you can you hear? Thank you for excellent presentations all around. Just before the meeting, I had the privilege of talking to one of the maintenance supervisors that was involved with installation of some of the posts, and he wanted me to convey the message. Again, I haven't been involved with it, but he wanted to convey the message that when you consider the fencing, wildlife fencing, please consider those as not reliable. And in other words, I understand that may be temporary anyway, but he wanted to emphasize that they're not properly funded, foundationed at the bottom, just conveying his message to you.
Yeah. We've been coordinating with our maintenance staff, and so I think we're going to reassess how we want to deal with that. And it wouldn't totally, resolve our issue with vehicle collisions. Ultimately, we want to build the entire project, but it could be beneficial for that area in the meantime until we go to construction.
Very good. And a question for Dan. I had the privilege of meeting your wife and two lovely children. What contribution did they have in your work?
My wife raised my daughters while I was doing my graduate research, essentially. So that's what she contributed by far. Yeah.
Katie, just for a little bit of cost perspective comparison, approximately what did the Rock Creek to Sherwin work over the last few years cost?
Off the top of my maybe that was that's much better. I don't have the figure right off the top of my head, but yeah, typical short shoulder widening projects in Mono County, could be between 30 and 40 million, depending how long they are. So yeah, our transportation projects are on par with what a wildlife crossing project can cost. We have lots of projects that breach the $100 million mark that are large scale projects. And so that's also something that, we want to ensure that people realize there are benefits to the transportation corridor and drivers from these types of projects. And I think that's why we've been seeing a lot of legislation going through and trying to have more funding for our agency to build these projects, because that's really been the thing that's been holding us back. It's not that Caltrans doesn't want to build these projects. We have no program funding for it. So I think once that starts to happen, you'll see a lot more of these projects getting built. Oh, we got some more online.
Yeah, there's a couple more online. I was just going to say maybe we'll take like 2 more questions here. But yeah, if you want to hit some of the ones online, and maybe while you're looking at that, I just want to ask Dan a quick question about, you have a lot of spatial data. Do you have any temporal data on like time of day that these animals are getting hit typically?
No, that was not something that we analyzed in this study specifically. However, in terms of temporal data of when deer are hit, basically deer are what we call crepuscular, meaning that they're most active in the twilight hours of dawn and dusk. So that means that they're likely going to be, crossing the highway in those times more frequently than they would in the middle of the day per se when they're bedded down, or the middle of the night. So yeah, that if you're interested in like when to look for deer at the the time of day, like when to be most vigilant, it would definitely be early morning and twilight hours, probably extending to late as 10 o'clock in the morning, and then similar in the evening, probably starting about 4 or 5, extending into the dark.
So when you guys drive home.
Yeah. So right now is prime time. Yes.
Maybe take 2 more.
I think there's, I was going to say, maybe you should answer this one from Kevin Kay. Have studies shown if predators migrate to crossings to catch prey using them?
So, yeah, that's an interesting one. There has been, we documented mountain lions and black bears using the Mammoth Creek undercrossing, as well as using some of those box culverts here in the project just through use of game cameras. So we know the predators will use those crossing structures. If they migrate, or if they go to those specifically to target animals, that's, I would say, unclear at this point, just from our study. Other studies, there has been some concern of that, but ultimately the amount of reduction in vehicle collisions outweighs the predator impact to those populations. What about
Lynn Bolton, okay. Sure. The drawing of the wildlife crossing showed 2 humps. Why not one big overpass? I think that was just the artist rendering of the overpass. I think the most common design now is just a bridge structure. And on 395 out here, since we have 2 lanes going